Good afternoon. So, I want to talk to you a little bit about data sheets today, okay, and how you're going to use them when you simulate circuits in Tinkercad, right? So, let me go on Tinkercad first of all, and I'm going to show you a little circuit here today. So, uh, let me move out of the way. There you go. So this is a little breadboard right here, that rectangle that looks like the rectangle that we have over there on the left. This one over here, okay. Over there I have a little multimeter. Here I have a voltage supply. I have several resistors. I have a push button. I have wires, resistor. This right here is a little LED. And this is a 74HCO4. Okay, so this is an integrated circuit known as an IC. And you see the little dot and notch right here. If I were to zoom in right here, you see that little notch right there. Okay, so that tells you that this is pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So now a big part of what we need to be able to do when we deal with building circuit is we need to know which one, those pins, what do they correspond to, what are they doing, okay. So what you can do is you can open a new tab like I have up here, and in this tab you're just going to Google 74HCO4, and this is what I got right here. Okay, so it's a Fairchild manufacturer. Doesn't have to be Fairchild, could be somebody else, but this is what we have. So this here is the layout of the pin. So you see that pin 1 is going to be an input. This is an inverter gate. Output pin 2. Pin 3 input. Pin 4 output. Pin 5 input. Pin 6 output. Pin 7, it says GND, so connected to the ground. That means the negative terminal of my battery or of my power supply, the black wire of my power supply. Okay. And then output, input, output, input, output, input. The reason I'm going over here from right to left is because of the number of the pin. Remember, it was 1, 2, 3, 4, 5, 6, 7, 8. Then pin 9, pin 10, 11, 12, 13, 14. And pin 14 is going to be connected to the 5 volts. Okay, 5 volts right here, VCC. Now, I'm saying 5 volts because that's what I'm used to when I deal with TTL. Okay, transistor to transistor logic. But if you look at this data sheet right here, this is not TTL logic. This is CMOS. Okay, you see this thing right here, CMOS. It says CMOS technology right here, and so it has the same functionality as the 74LS logic family, but the voltage levels are slightly different. Okay, so if I look below to the second page right here, you see that the supply voltage, VCC, is going to be okay between 0 volt and 7 volt. Okay, and then the pin out of the IC will supply 25 milliamps. Okay? So let me show you what it means right here. So pin 7 right here connected with the black wire to the negative terminal of my power supply right here. Okay, and this pin on top, pin 14, to the positive terminal of my power supply right here. Okay, then I have my integrated circuit. This pin right here, pin number 1, is an input that comes from that switch right here. Okay, so when this switch is depressed, essentially we have a low signal that goes through that resistor, and that goes over here, and when you press it down, it goes from the positive terminal right here to this. So let me show you with the simulation here. Let me start the simulation. So you see that my power supply is set at 5 volt, okay, and right now at that pin, the pin that is connected to my push button, I'm seeing 0 volt, okay, and my LED is on. I want to show you that if I put my cursor right here over the push button and if I push, then the voltmeter tells me that I have 5 volts at the pin of my input pin on the 74HC04, and I can see very clearly that my LED is off. If I release, the voltage on the input is 0 volt and my LED is on. Okay, so you see that this is indeed inverting the signal. If the input signal right now is 0 volt, the LED is on. That means it's receiving 5 volt. And if the input is 5 volt, we can see that the LED is off, hence the term inverter. But what I want to show you is this. Right here, I see an input voltage of 5 volts, okay? And my LED is on, everything is okay. What happens if I decrease the voltage? Well, you see that the LED is still on, maybe a little bit dimmer, but the LED is still on right here. Now it looks off. And we could calculate it by using the fact that we might not have enough current for the LED to stay on. But let's try to go in the other direction. Remember on the datasheet, it says that the input voltage can go up to 7 volt right here. Okay, up to 7 volt for the input voltage. What happens if I go beyond 7 volt? That's what I want to show you right here. So let me go a little bit beyond and keep your eyes on the LED and on that number up here on the power supply. You see I'm above 7 volt, and what do you see on the LED? This device broke because of supply voltage is 7 volt, while permitted range is between negative 0.5 volt and 7 volt. Okay, so it refers back to the fact that the manufacturer left an operating range of voltages for this IC. Okay, so we don't use the data sheets very often, but we use them to know the pin layout, and if we have issues to figure out the voltages needed for things to work correctly, as well as the current sourced and synced into the IC, as well as much more rarely the transient time or the temperature range of operation. Okay? Now, all those elements right here are found in Tinkercad on the right. You even see a lemon battery right here, but you see a 9 volt battery, you see a bunch of things. So we'll get to play a lot with that, but I just wanted to show you that these are not just images, but they are well programmed, well coded elements. Okay, I hope this was helpful.